Jai Hind, myself Neha Garg, and I am going to give lecture on the topic clipper, series and parallel clipper. This topic has been taken from the subject Fundamentals of Electronics Engineering, BEC 101. This subject is currently running in the syllabus of AKTU. So first question is arises that what is the clipper? So clipper are basically the circuits that have the ability to clip off a certain portion of the input signal and without distorting the remaining part of the alternating signal. So clipper may be of two types, simple clipper and parallel clipper. In simple clipper, like circuit is in this way. This is the circuit for the simple clipper and this is the circuit for bias clipper. This is the VI signal and here it will be the output. This is the input and this is the output. So here we are getting the output and here we are getting this is our input. So there is no biasing here. So this is the simple circuit for the clipper, and here there is a biasing of plus minus. So this is the bias clipper circuit, and here diode is in series with the input supply. So this is a series clipper, and if the position of the diode is in the parallel with the series clipper in the input voltage, like this is the circuit. Now diode is in parallel with the input supply. So this case is for the parallel clipper, and this circuit is for the simple parallel clipper. And if I apply biasing here, so if I apply biasing here, so it means this is the parallel biased clipper. So a clipper, if we can see in this diode will be forward biased for the positive half of the input cycle. Like this is the input wave. So for this positive half, this diode will be forward biased. So for that, when it will be forward biased, it will be short circuit. So in that case, output would be equal to Vm if the peak value of the signal is Vm. So and in negative half cycle, this diode will be reverse biased. So in that case, this will be open circuit and output would be equal to 0. So we can say only for positive cycle, this diode will be conducting and there will be output. So it will clip the negative cycle of the input signal, and that's why it will be called as a negative clipper. And in this circuit, if the orientation of diode is reversed, like if the orientation of diode will be like in this way, so in that case only negative cycle will be passed and positive cycle will be clipped, then it will be called as a positive clipper. Like these are the different series clipper and series clippers with idle diodes. So here these are the idle diodes here, and this is the series clipper. So in this lecture we will take all the circuits one by one. So this is the first circuit, second circuit. So these are the positive clippers. We can see this is our input signal and this is our output signal. Here positive cycle has been removed in the output. So that's why positive cycle has been clipped and it is called as a positive clipper. And here also we have applied this biasing here. So with the help of this biasing, the forward voltage across this diode has been changed, and that's why positive cycle is completely removed and negative cycles, and we are getting the negative cycle with changed waveform. And here the polarity of the battery is reversed, and that's why positive cycle has been removed and the amount of this negative cycle has been changed by this amount of voltage. So this is the simple clipper, and these are the biased clippers, and all these are the positive clippers because positive cycle has been completely removed, and these are the negative clippers because there is no negative cycle here. Negative cycle has been completely removed, only we are getting the positive cycle here. So these are the negative clippers because negative cycle has been removed. This is the simple negative clipper, and these are the biased negative clippers. And all these diagram belongs to the series clippers because diode is in series with this power supply. So first diagram is this. This is our diode. So first of all, we will see when we analyze any clipper circuit, we will see in which condition our diode will be in conducting state. So this diode will be in forward biased in the negative half cycle of the input signal. So diode is forward biased in negative half cycle. In negative half cycle, diode is forward biased. Diode is forward biased. So in that case, equivalent circuit will be like in this way. Diode will be short and output voltage would be like V0 plus minus, and this will be Vi plus minus. So diode will be short in this case. So output voltage would be equal to Vm. If we apply the KVL, then V0 would be equal to Vi. This V0 would be equal to Vi. We can apply KVL in this part, and that case V0 would be equal to Vi. And in positive half cycle, in positive half of the input signal diode is reverse bias. So diode will be open circuit. Diode will be open circuit, and in that case diode will not be conducting, and output voltage would be equal to 0. So if we draw the waveform like in this way, this is our input signal, this is T, and this is Vi, and we are drawing the output like in this way. This is our output, and in negative half, output is V0 is equal to Vi. In negative half, output is equal to Vi, and Vi we can see it is going towards negative side. So here will be like in this way, and for positive half cycle, output is 0. So it will be 0. So this will be the output, and here peak value is equal to minus Vm, because here it is V minus Vm and here it is plus Vm. So this will be the output in case of the series clipper. This is a positive series clipper because positive cycle has been removed here. And now this is a biased series clipper. So for that case, first of all, we will find in which condition our diode will conduct. So for that case, we have to find the potential at the P plate. This is our P plate and this is our N plate. So this plate P is connected with this supply Vi and V. So potential at P plate would be equal to P, and N at P plate it would be equal to Vi minus V, and N plate is connected with the output. So if when we determine the state of the diode, in this condition diode is not conducting. So in this case always the output would be equal to 0, because diode is not conducting in this state, no current is flowing across this resistance R. So output is 0, and that's why N plate is connected with 0. And for diode to come in the conducting state, it is essential that the potential of the P plate must be greater than the potential of the N plate. So this would be the condition, Vi greater than V. For this condition, diode conducts. And then equivalent circuit would be equal to, this is plus, this is minus. The diode will short if it is conducting, so it will be replaced with short circuit. This is I, this is V0. So in that case, by applying KVL here, we can find Vi minus V is equal to V0. So this is the value of V0 whenever diode is in conducting state. When diode does not conduct, this will, so reverse condition, that is Vi less than V, diode does not conduct. Diode does not conduct, so equivalent circuit will be like in this way. Now it will be open. This is the resistance. This is V0 plus minus. So plus minus V. Here Vi plus minus. So in this case, diode is open because diode is not conducting. So output would be equal to 0. Output is 0 in this case. Now waveform, we can draw the waveform like this is our input signal, and we can see the threshold value from here. Vi greater than V, for this condition our diode is conducting. So we have to draw the line that corresponds to V. Now we have to find the condition when for this reason where diode is conducting. So for Vi greater than V, diode is in conducting state. So for this reason, this is the conducting reason. This is conducting reason. In this condition reason, diode is conducting. So we can draw perpendicular from this reason, like in this way. Now we can do the marking A. This point is B. This point is C. This point is D. This is E. This is F, and this is G. Okay, so now for this reason B, C, D, diode is in conducting state. So diode is in conducting state. So here out when diode is in conducting state, output is equal to Vi minus V. So at point B, output is equal to Vi minus V. So and value of Vi is equal to here V. V minus V, it would be equal to 0. So this would be V. And at point C it would be equal to V naught would be equal to Vi minus V, that is Vm minus V. So this would be equal to Vm minus V. This is Vm minus V. Vm minus V. Okay, and another reason diode is not conducting. So there will be a 0 output here. Okay, so its waveform would be like in this way. Okay, so in that reason only B, C, D, in this reason diode is in conducting state. So here output would be equal to Vi minus V, and we have to place the value of Vi here. At this place C point, the value of Vi is Vm. So this point would be equal to Vm minus V, and rest points, these points are 0 at 0 because the value of Vi is equal to V. So V minus V would be equal to 0. And all that reason, these are the non-conducting reason, and non-conducting reason the output is equal to 0. So output waveform would be in this way. So this is another circuit for the negative clipper, and this is a simple circuit, and we can find out in positive half. In positive half of the input cycle, diode will conduct. So diode conducts. In that case, equivalent circuit would be equal to like in this way. So output would be equal to Vi when diode conducts, and in negative half, diode does not conduct. So in that case, diode will be open circuit, and equivalent circuit would be like in this way, and in that case output would be equal to 0. So if we draw the waveform, we will be having like in this way. This is our input, and for output we are drawing perpendiculars, and we can see for positive half there will be output, and that will be equal to Vi. So this is the output. This is Vm value corresponds to this Vm value, and in negative half we are not getting any output. So this is a negative clipper, example of negative clipper. This is again, here we can see, now we have to find the potential across the P plate and N plate. Here this is your N plate and this is your P plate. N plate, at N plate potential is Vi minus V, and P plate potential is 0. So Vi minus V must be less than 0. So Vi must be less than V. For this condition our diode will conduct. So equivalent circuit will be like in this way. This is R, V naught plus minus Vi plus minus, and this would be equal to plus minus. plus minus V. Okay. So in this case, output, if we apply KVL in this circuit, we will get output voltage would be equal to Vi minus V. In this case, output will be equal to Vi minus V. And in reverse state, Vi greater than V, diode does not conduct. For this state, diode does not conduct. And in this case, the equivalent circuit would be equal to, this diode will be now open, this resistance, output would be equal to 0. This is plus minus V and this is Vi plus minus. Okay, so in this case, output would be equal to 0 because diode is open and no current is flowing through the circuit. Output would be equal to 0. Now we have to draw the waveform. So this is our input signal, and now we have to draw the threshold line. That is, we can be for drawing the threshold line, we should always see the state conducting condition. So in this condition, diode will conduct Vi less than V. So here V is positive. So if V is positive, draw the line at the positive axis. That is our V. And if this V is minus V, we have to draw this line in the lower side, negative side. Now these are the intersecting points. So we have to draw perpendicular from the intersecting points. Now we will draw these perpendiculars. Now we have to find the conducting region. So this is the Vi that is less than V. So this shaded part is our conducting region. Vi less than V is conducting region. This is our V. So less than Vi, that is less than V is this part. So this is our conducting region. And for that conducting region, we have the output Vi minus V. So we can give the name to this conducting part A, B, C, D, E, F. So at A point, output would be equal to Vi minus V at this point. And at this point, the value of Vi is 0. 0 minus V would be equal to minus V. So for that point, I will put here minus V. And at B point, output would be equal to Vi minus V. And here the value of V at B point is V, equal to V. So V minus V would be equal to 0. So here this point would be, it will be equal to 0. Similarly, at C point it would be equal to 0. So this curve would be, so this would be like in this way. Okay, and B, and between B and C is the non-conducting part, and here the output is already 0. So this line will be equal to this way. Okay, this will also be minus V here. At D point, output would be equal to minus V, and at E point we can calculate Vi minus V. At E point, the value of Vi is minus Vm. So it will be equal to minus Vm minus V. So here it would be equal to minus Vm minus V. And here again at F point it will be equal to minus V. This is at minus V. At F point also output will be equal to minus V, because at F point we will put Vi minus V, and at F point the value of Vi is 0. So 0 minus V would be equal to minus V. So this will be our output waveform. Now again next circuit. So in this circuit we have to find the potential across the P plate and N plate. So at N plate it will be N plate Vi plus V, and at P plate it is 0, so less than 0. The potential of P plate will always be greater than potential at N plate, and N plate it will be Vi plus V, and in P plate it will be 0, because there initially diode is not in conducting state. So it will be Vi less than minus V. For this condition, diode conducts. So output would be equal to This diode will be short now. The resistance is this V naught plus minus Vi plus minus, this is minus, this is plus, this is V. So V naught would be equal to Vi plus V. This is the case whenever diode will conduct. So output will be like in this way. And for the condition where for condition like V greater than V, diode does not conduct. For this condition, diode does not conduct. And equivalent circuit will be, okay, diode will be open now. So this part will be open. This is open. And this is resistance V naught plus minus Vi plus minus. This is minus plus V. So in this case, output would be equal to 0. In this case, output the diode is open here because it is in non-conducting state. Now the equivalent waveform would be like in this way. This is our input signal. Now we have to draw the threshold line. Here we can see Vi less than minus V. So we will draw this line here at minus V. Now intersecting points, this is the intersecting point A1, we have to draw line like in this way. Another intersecting point is this, one intersecting point is this, another intersecting point is this. Okay, now we can give the names to these points A, B, C, D, E, F, G. Okay, now we have to find the conducting region. So we can see Vi less than minus V, diode conducts. So Vi, this is our minus V, and this is our Vi less than minus V. So this region is conducting region. Okay, so we can see in conducting region at point D, output is equal to V naught is Vi plus V, because at D point is on the conducting region. So at point D the potential output is Vi plus V, and the value of Vi at point D is equal to minus V. So minus V plus V is equal to 0. So here it will be equal to 0, and at point E its output is Vi plus V, and the value of Vi is minus Vm plus V. So this point minus Vm plus V, and at point F output is V naught is equal to Vi plus V. The value of Vi is 0 here, not 0, it is minus V and plus V, it will be equal to 0. So this is the output at D point, this is the output at F point, and this is the output at E point. And other points A, B, C, output is automatically 0 because they are the non-conducting regions. So here it will be this line, this is the output. So only in that region our output will be there. So it has clipped completely positive cycle. This is an example of positive clipper, biased positive clipper. Now next waveform, again here we have to find the condition where diode will conduct. So here P plate potential is Vi plus V, and it will be greater than 0. Vi plus V. So it will be Vi minus V. For this condition diode conducts. For this condition diode will conduct, and equivalent circuit will be like in this way. So here if we find the output voltage, we will apply KVL here, and V naught would be equal to Vi plus V, and for reverse state Vi less than minus V, diode does not conduct. In that case equivalent circuit would be equal to, this diode will be short now, resistance, this is V naught plus minus, this is Vi plus minus minus plus V. So here output would be equal to 0. Now we have to draw the waveforms. So this is our input waveform, and now we have to draw the threshold line, that is of minus V. So this will be our minus V, and now we have to draw the perpendicular lines from here. Okay, now we have to find the conducting regions. So for Vi greater than minus V, so this part will be the conducting region. This is A, this is B, this is point C, this is point D, E, F, G. So this shaded part, this is the conducting region part. So in conducting region, at A point, output is, at A point, output is equal to V naught is equal to Vi plus V. So at Vi, at A point, the value of Vi is 0. So 0 plus V would be equal to V. So here output will be equal to V. At A point, output is equal to V. And B point, at B point, V naught is equal to Vi plus V. So it will be equal to Vm plus V. So it will be equal to Vm plus V. And at C point, it will again equal to V. And at D point, V naught would be equal to Vi plus V. But the value of Vi at D point is equal to minus V. So when V minus V plus V is equal to 0. So it will be equal to 0 here. And DEF is a non-conducting region, so output will remain 0 here. And again at G point, output will equal to Vi plus V, and the value of Vi is 0, so automatically it will be V. At G point, the value of output will be equal to V. So this is again, here we can see negative cycle has been completely removed. So it's a negative clipper, negative bias clipper. So in next lecture we will discussing about the parallel clippers, and rest of the series clipper will also be covered in that lecture also. So thank you.